and we talk about the basic. This is can be used as a sensor, can be used as an actuator. This is electrical components and switching and solenoid type devices. So, and here are today's objectives. And we want to learn the relays. Have you guys ever heard of the relays? Relay. Jessica, what's a relay?
I mean, I can't tell you what it is. I've heard of it though.
Okay, relay. Okay, relay. I'm not talking about Olympic game relay.
I'm not talking about a race either.
Yeah, it's Olympic game relay is very close to this one. Very close in the meaning. Right, relay means that I do something and then other people will do another thing. The relay is the same thing. Okay, thank you, Jessica. And we want to know. We want to create a simple relay circuits and move forward and reverse control for the motor. I'm going to show you guys. And we want to learn the procedure for selecting a solenoid. Have you guys ever heard of solenoid? Huh?
Yeah.
Harry, what is solenoid?
It's like a locking mechanism.
Yes. Good. Yes. Okay. It's a locking mechanism. This can be used as an actuator. Learn the implementation issues of this solenoid. Good. I love you guys so much. So why it comes twice? Huh? Switching devices. And switching devices, mechanical switches, relays and contactor. You should know that, okay? So maybe you have heard of relays, but maybe you have never heard contactors. And contactors is a bigger relay, and contactor is also a relay. So large relays are called contactors. In addition to mechanical switches, they can be used as the actuator or can be used as sensors. It depends on how you call it. And then we talk about the solid state switches, the diodes, thyristors, and the transistors. And have you guys ever heard the diodes, guys? Diodes, we will talk about diodes and thyristors and transistors in detail in the following class. But today I want to tell you some basic things. And diodes means that this is an electronic device, a very basic electronic device. So this current can go only in one direction. All right? And the symbol shows the current can go from this end to that end. And reversely, no current. Theoretically, no current, but still a little very tiny amount of current. So this is one direction. This is diode. So this is a thyristors, and the thyristors, this is thyristors. And this is thyristors, and we have this is a PNP. This is a transistor. Okay, this is a thyristors, and this is a thyristors. And thyristors. And we have this symbol. And we have this is A. And we have this gate. And we have this K. So this symbol. It is a three state. This is the terminal, the four layers, a three terminal electronic. So this is a gate. Right? This gate controls whether this current goes through or no, from this A to K, or from K to A, from A to K, I'm sorry. And then we talk about these transistors. The transistors the transistors, they have two different kinds of transistors. We have this, the PNP. This is the first one, is a PNP. And here is the base. This is the base, the B, and B is the gate, and we call base. Is the base, and here. So this is the emitter. Emitter. So this is the direction symbol. And here is a collector. C is a collector. It's very intuitive. Collector means collecting the current. So here is a PNP transistor. And I also have NPN transistor. And NPN, I want you guys to write this down, okay? And so in the details, I will talk about this in detail later. But still, I want to have some sketchy idea. We will use this one very, very often. So this is the NPN. NPN, we also have very similar symbol. So here, so we have a base. This is a base. This is a base here. So here is also, and C is also collector, okay? C means collector. So here is a E. E means emitter, and E means emitter. Emitter means something that is emit things, emit current. Okay, and how these two guys work? Read my lips. The voltage of for this one, the voltage of this. If the voltage VEE is greater than the voltage of threshold. If this inequality holds, there is current. So this condition applies for both of these two cases. If this inequality holds, that means the current can go through. Otherwise, theoretically no current. Even though very, very tiny, but theoretically in series very tiny, but practically we call no tiny. Otherwise no current. I read this is using quotation mark, no current. Applicably, we just say no current. But it's theoretically it's very tiny. Very tiny is ignorable. We just ignore it. Question so far? I want you guys to know this, okay? Ethan.
In the inequality at the bottom, what's the subscript on the second V there? V.
You see this one?
Yeah.
TH.
The
threshold. Yeah, threshold value. And this threshold value is dependent. Very good question. And this threshold value is dependent upon the material you are using. If you are using silicon, or using germanium, or using other semiconductor materials. Very good question. Your name is Ethan, right?
Hayden.
Hayden. I'm sorry.
You're good.
Hayden. I'm recording my students' names. Very good question. I want you guys to know this because on both for our the first exam quiz and first exam, and I will ask you guys to interpret on how this circuit works. How it works because we have transistors, and you need to know on how this guy works. This guy is Dylan, right?
Yeah. What's the difference between the NP and the N?
So it is depend on what is the semiconductor material you are using. Between the different semiconductors.
Okay. So like, is the top one different than the bottom one?
Yes.
Is
Because
it the direction that the E is in?
Yeah. NP. One we call N, one we call P. When N we use the doping element, we get the N material. If we use another doping material, and we get a P. Okay, I will talk about this one later in detail. But because we have other the contents for this course, I want to make sure that this one can be a standalone lecture. But the bottom line is that you know that the inequality. If the inequality holds, that means we have current going through. So this is switching devices. So now we come back the relay. What is a relay? A relay used as sensors to give impulse to systems, and can be used as sensor. Also can be used as a relay, or can be used as a actuator. If some conditions are met and you want this relay to work, in this case, this guy will be called actuator. And it's just a simple on and off switch in response to control signal. A relay isolates the control circuit from the power circuit. So this is very, very important. For the control circuit, I want to write down, okay? For control circuit, and the voltage is so low, it's about 12 volt VDC or 24 VDC. Write down as what is a control circuit? Can be 5 VDC TTL, and can be 12 VDC, can be 24 VDC, very, very low. That is harmless to our human bodies. And however, the voltage, power circuit is usually very, very high. 110 voltage can kill people very, very easily, right? Maybe for this is a highly duty things, for example, the waters, that is the 240, right? So one is called control circuit, one is called power circuit. Control circuit is powered by very, very low voltage. Power circuit is controlled by very, very high voltage.
Doesn't the like potential difference or voltage difference for like if it can harm someone not matter if the current is low enough?
That's a good question. Usually the 1A, the ampere, 1 ampere can kill more people. I will not say that. Very bad, right? If I can kill a living organism instantly and burn the living organism into ashes instantly, 1 ampere, 1A. So stay away from these high voltage things, right? For our health and well-being. A small voltage we use a small voltage to the solenoid control a potentially large current through the relay contacts. Why it come by again? I don't know. So how the relay works? You can see, and we use so here is the coil, a group of coil, and they are located, and this is a group of coil, and here is a set of contents, and you can see at this instance, so this set and this set, they are separate, right? They are separate, and if you can wear some components here, and now at this instant, and so this is no power. And however, if I energize this coil, because if the coil is energized, what will happen, guys? Magnetic field will be generated. Do you guys agree? If the magnetic field is generated, and then, so this is coil, we will have north pole and south pole. It depends upon on how you wind this coil, right? So then, and this magnetic field will pull this armature down. If this guy pulls down, so here and this guy will be contacting each other. So these two guys will be contacting each other. You can see if you control this coil, and you can control these two sets of contents. This is how it works. This is a working principle for the relay. A set of coil is energized, a magnetic field is generated, and then the armature is pulled, and then, so this is the set of contents. They just change their status. Sometimes initially, some they are open. Initially, some are closed. However, after the coil is energized, and they just change the status. Okay, from open to close, from close to open. So here is what I just described. electromagnetic coil and pulls armature 2 were energized. The mechanical linkage 3 transmits the motion to one or more contents. Normally open, normally close, and the transfer contents will change positions. Here, you can see this is a more intuitive one. If I energize this, then I will pull this, right? If I pull this one, originally these two guys are separate. If I pull this linkage, so this guy will contain this one. So this way, the content here will be separate. So this one will contain this one. That means that the status changed to the opposite. Why it goes twice? I don't know. So here is the logic, relay logic, motor reverse. This motor reverse shows the simple application of this is how we control. Now, at the very beginning, I suppose at the very beginning we have this configuration. Now this is a cathode and this is anode. So the current goes this way. For this motor, the current is going from the top to the bottom, right? And however, if we change it, if we just use armature relay, right? Relay, and when we put this arm from here to here, and this arm from here to here, what will happen? If we put arm from here to here, then so this is cathode will go this way, and so in the motor, the current goes from bottom to the top. So you just change the current direction. As a result, the motor direction will be changed. We change the motor direction by changing the current direction. So this solenoid, and then we talk about the solenoid. The solenoid, look at it here, okay? Solenoid, this is how solenoid works. On solenoid, we have a housing. We have a housing, continuum, this material housing. We have a coil, a bunch of coil here, and we have a plunger, right? And also the same, very same principle as the relay. And if this coil is energized, the magnetic field will be generated. As a result, I can just attract this magnetic field will attract this plunger. You guys agree? For example, this is the plunger. Okay, this is a plunger retracted. This is a plunger extended. At the very original, this original configuration, the plunger is in this place, this location. If this coil is energized because of the electronic field, magnetic field, so this plunger will be retracted, right? You understand, guys? So that plunger is moving from original configuration to the final configuration. So using this, we can do a lot of things. We can use application, divert, peak, length, lock, pin, pitch, and position control, and valve control. We can use this, just use this, the principle. So intuitively, you can buy this one. You can buy this kind of, this is solenoid. For this one is unactuated, and so this one is actuated. So this one is actuated. And some students might ask, Dolma, this one and this one, it looks in the opposite way, right? Yes, it looks in the opposite way. And how can we accomplish this? I can just open a hole here, right? I can just and put this pole on this side. You agree? And then I can have push. This is called push type solenoid. But this one is a pull type. This is a pull type. This is a push type. It depends on how you use it. Understand, guys? I might ask you guys on how to change from pull type to the push type. So you can just from the back stop, you can just open a hole and put a pole there. So constructions. We know that there must be a housing, and this is a container. The core of the solenoid usually made of two sections. And we have a core. This is a movable actuator or plunger. A fixed end core or backstop to the end. So when the coil, we must have a coil definitely. When the coil is energized, a magnetic field is created between the plunger and the coil, plunger and the coil, and then causing the plunger to travel from the original location and to this is the retracted condition, usually close to the backstop. So when the de-energized, that means when we just shut off the energy, the power, the solenoid lost its magnetic field, magnetic force, and allows the plunger to return to its original section, position. The material of the central guide, usually is the glass, filled nylon, and brass, and the plating of the plunger, electroless, nickel plating, or other low friction coating are chosen to reduce friction and wear. We know that the plunger will be translating, will be traveling within this house, right? So within this is housing, and so this is the how to minimize the friction between the plunger and this coil, and that is you need depend upon what material you are using. Why it comes back again? So how to select a solenoid? Especially for you guys. You are doing senior designs, right? Maybe for some senior groups, you need to select some solenoid. How to select solenoid? So you need to consider the packaging length, how long it is, depending upon your whole system. For your whole system, how big your whole system, how big the other components are, and how can you fit this solenoid and integrally in your whole system, the length and cross section, and the stroke. And this stroke means the distance traveled by the plunger, right? The stroke has different meanings, right, in the different contexts. You guys know stroke? Do you know stroke? If you do not know stroke, congratulations, you are very, very healthy. If you have never heard stroke, congratulations again, and you are living in a very, very healthy environment. Let's go, is it right? You know stroke, right? Stroke means the blood vessel is blocked with people. Here is a stroke. Stroke means how far something is moving. Well, here means how far the plunger is moving. You know stroke, right? I'm kidding, guys. I'm kidding. I have a classmate. He had a stroke. I feel very, very bad for him. I feel very bad. I love him very much. So stay away from stroke, okay? The force. Second, next thing is the force. And what kind of, how much force this guy can provide when the plunger is moving? And AC, DC. And AC means alternating current, right? So this is alternating current. And DC is the direct current. Should I use the AC or should I DC? And what is the benefit for using AC? What is the benefit for using DC? Let me tell you, DC is more reliable, also cheap, safe. AC is more powerful, but you need to be very, very careful. What? So maximum on time and minimum off time. So maximum ambient temperature. And when this guy is working, if this guy's ambient temperature increases substantially within a short time, and you need to be very, very careful. And we are going to talk about the strategies to reduce the energy consumption and at the end of this lecture. So all solenoids put the plunger into the coil when energized. Okay, so these all put the coil into the coil when energized. So that's the reason I told you guys the original type of solenoid is a pull type, right? I might ask you guys, as I said, how can we get a push type? How can we get a push type? And we just open a hole at the backstop and a pole. That will be push type. You understand, right? But all the original solenoid is a pull type. So however, solenoids can be equipped with a push rod mounted to the inner end of the plunger, on which extends through a hole in the backstop, and thus when the plunger is pulled into the coil and the rod extends back, producing a pushing motion. So I will test your understanding, okay? I might ask you a tiny question. How can we change a pull type solenoid into a push type? So return stroke, okay? After I energize my coil, the plunger is retracted. After I de-energize the coil, how can I make sure my plunger can be stored into the original position? Usually you need some help, and we need some by the load itself or by return the spring, right? We have to put a spring there. Whenever there is no magnetic field, this spring will push the plunger back to its original position. All forces that the solenoid must overcome to move and seize the plunger. The forces, you need to talk about forces. And when this plunger moves from the original position and to the retracted position, and you need to the system needs to overcome all the forces. What are all the forces? First, the return spring force if you have a spring. Also the friction. The weight of the plunger if the solenoid is to be pushed in the vertical mode. This itself is weight, and also the friction. Why it comes twice? This is what beyond me. This is the characteristic curve. The force initially developed by the solenoid is dependent upon the stroke. And for instance, the longer the stroke, the smaller the force. The longer the stroke, the smaller the force. You can see at the very beginning, the force is very, very high. Also, the force versus stroke relationship is known as a characteristic curve. For different head, and we will have different these characteristic curves. You should know that. Okay? For the flat or conical 90 degree or conical 60 degree, and we have different curves. When you buy the solenoid, and you will get the data sheet from the vendor, from the manufacturer, and then you will know all these details. So variation in nominal voltage. Select a solenoid based upon the lowest anticipated and supply voltage. A variation in the temperature. This increase in the coil temperature. If the coil temperature increases, and you will increase the coil resistance, reduce the current, and decrease the output force. This is output force. I don't know where it goes this. So this is, should we select the AC or DC? Here are the advantages of selecting DC solenoids, and here are the advantages for selecting the AC solenoids. So for AC, incorporate laminated cones to reduce eddy current losses, provide a large magnetic force at a greater stroke, and that comparable DC system. As I said, usually, this AC solenoids is more dangerous. You need to pay more attention. The duty cycle. The duty cycle means on and off, and how it goes on and off. So one way to reduce the amount of excess heat generated at a higher input power is to use a solenoid intermittently. That means I will not energize my coil continuously. Sometimes I energize it, sometimes I just turn it off. The duty cycle is a ratio of on time over the total time for any one cycle of operation. Usually duty cycle is expressed in percentage. So duty cycle, you have this concept in your mind, duty cycle. So this is how we calculate the duty cycle. If the maximum cycle time is greater than the specified time in seconds, a continuous rotated coil solenoid 100% must be used. Okay? However, the duty cycle is given by this on time divided by the total of on time and off time. So while continuously duty 100% duty cycle solenoids provide a margin of safety against the overheating and coil failure, and they provide less pull force than intermittent. So it ensures the maximum on time does not exceed the recommended limit for particular solenoid. And pay attention to the heat. The temperature. So the limiting factor for operating temperature is usually the rated temperature of insulating material used in the solenoid. We have four classes: A, B, F, and H. So, and here are the strategies of reducing the energy consumption, and I will test your understanding of this. So I'm going through very quickly. Okay. First, apply a voltage to the solenoid coil and to provide the unnecessary force to pull the plunger in, and then when seated, drop the voltage. Is one thing, and to a sufficient level. And second one, peak and hold module are designed to apply an initial higher voltage to the coil for a predetermined period of time, and then drop the voltage for predetermined percentage of the initial value. This second. Third, in the cases where the voltage cannot be dropped, similar results could be achieved by placing a resistor in series with the coil when the plunger is seated. When you place a resistor, this resistor itself will carry some voltage. That means will just dissipate some energy loss, heat. Okay, so this is the third of the strategy. So next strategy is we use two things, two weldings. So initially, we energize the both welding are electrically in parallel. So when plunger is seated, one welding, usually the low one, consumes more power and will be disconnected from the circuit, while allowing the other welding to remain energized, holding the plunger in position. So this is the okay. One more second. So here is a key assemble considerations. And now I want you guys to understand this. So this is a rotary solenoid. This is variation. Okay, and you guys just take a look. Now this time, and when the coil is energized, the plunger will be retracted from this position to this position. Rotary is a rotary, not oscillating. The reference websites here, and here is what we have learned today. So think about these four questions. What is a working principle relay? What is solenoid? How does it work? What should we consider when selecting solenoid? Finally, and what are the commonly used strategies for reducing energy consumption?